Yeah. Number 15. So number 15 says, a 5-year-old child receives an allowance of $1 per week. His parents promise him an annual increase of $2 per week. Write a formula for the child's weekly allowance in a given year. Explicit. What will the child's allowance be when he's 16 years old? So what I'm looking at is, so he's 5 years old right now, right? And he gets a $1 a week allowance. So when he's 5, he makes $1 a week. We could think of that as our first term. In other words, that's when he's 5. He gets $1 a week. When he's 6, what did it say? It said $2 increase? Yeah, $2 increase. So when he's 6, he's now going to make $3 a week. When he's 7, he's going to have $5 per week. So this is going to be an arithmetic sequence. So dollars per week is going to be 1, 3, 5, 7, so on and so forth. So our arithmetic sequence is just going to be a sub n is going to equal the first one, which is 1, and then I'll be plus that n minus 1 times our common difference. Our common difference is 2 because we're adding 2. And that's how you come up with your formula. And then I think it says after 16 years old how much you're making. We just plug a 16 in for that n.
Okay, got it.
Cool. Did you still have a question?
No.
Okay, that was it? Cool. Other questions, though? Okay, then let's talk about today. We're going to talk about geometric sequences. So yesterday we talked about arithmetic sequences. Arithmetic sequences were adding the same number over and over and over. Geometric is going to be very similar, except for addition, we're going to change it to multiplication. So a geometric sequence is a sequence whose consecutive terms have what's called, so yesterday we had a common difference, adding or subtracting. Today we're going to have a common ratio. A common ratio. And rather than a lowercase d, we're going to use a lowercase r to stand for our common ratio. So we're looking for a number that multiplies over and over and over and gets me to all the other terms. Yesterday I said the easy way to come up with your common difference is actually just to look at it. But I said another way is to take like your second term and subtract your first term from it, and you get your common difference. Today, to get a geometric sequence or an r value, we can just take the second term and divide the first term. Most of the time, you're just going to be able to see. Like yesterday, you could just see if you're adding 2, subtracting 2. Same thing's going to work for geometric. You're going to ask yourself, what times, or look at this case. We have 1 to 2. 1 times what gets me to 2? 2 times what gets me to 4? 4 times 8 gets me, 4 times what gets me to 8? If you're ever stuck, like I said, just take your second term, divide your first term, and you'll get your common ratio. So I'll put that off to the side, but I'm not going to do that all the time if I was you. So that would be our r common ratio. So are the following geometric sequences? If so, state a common ratio. In my mind, the first thing I'm going to check is arithmetic because it's easy to check. +1, +2. Nope, it's not arithmetic. So my next thing is maybe it's geometric. For it to be geometric, we have to be multiplied by the same thing. Like I said, you can get your common ratio by just taking your second term, dividing your first term, which would equal 2. So to get from 1 to 2, we need to multiply by 2. To get from 2 to 4, we multiply by 2. To get from 4 to 8, we multiply by 2. So is this geometric? Yeah, it's geometric. And on top of that, our common ratio equals 2. Now, just like an arithmetic sequence, the two important things that you need to locate are your first term and your common ratio. That's how we're going to get to the two formulas we're going to get to in a second. All right, our next one. Once again, if you're not sure if something's being multiplied, first of all, it's not being added. 2 to 8 is 6. 8 to 32 is not 6, so it's not being adding. We could try to change our denominators to all be 128. It's a lot of work, and it's not going to work. So the next thing I'm going to look for is a common ratio. If you do not know what it's being multiplied by, you can take the first term, or the second term divided by the first term. Now remember, keep, change, flip is keep the top fraction, flip the second fraction, so I have 1 over 8 times 2 over 1, which is going to equal 1 over 4. So if this is geometric, it means I'm multiplying everything by 1 over 4. Let's see if that's true. To get 1 over 2 to 1 over 8, if I multiply by 1 over 4, yeah, that equals 1 over 8. If I multiply 1 over 8 by 1 over 4, 4 times 8 is 32. Yeah, that works as well. Multiply by 1 over 4. 4 times 32 is 128. So this is geometric. I'm multiplying by the same number over and over again. And like I stated above, our R value is 1 over 4. Our common ratio is 1 over 4. All right, so the only difference between yesterday and today is today we're looking for multiplication. Yesterday we were looking for addition and subtraction. Just like yesterday, we're going to have two formulas. We're going to have a recursive formula, and we are going to have an explicit formula. Both of them require us to know our first term. Now, for recursive, just like yesterday, you do have to state what is your starting term. So what is my first term? Where do I start from? Now, remember, for recursive, everything's based upon the number before it. Yesterday, our formula was the term that I want equals the term before it plus a common difference, d. Well, we aren't adding this time. This time we are multiplying, so we should treat it the same. We're going to go the term I want equals the term before it times our common ratio. So we got our term I want equals the term before it, but in this case, we usually put the R out front. If you put it after it, it's fine. If you just go the term I want times R, that's fine. It can help you remember it because one is plus D, the other one can be times R. It's just typically in math books, you put the R out front so it doesn't get lost into this n minus 1 land. All right, that's our recursive formula. For explicit, it's going to be a little bit different. We are going to go a sub n. Just like in the explicit form of arithmetic, we're going to start with our first term. But here's where it gets a little bit different. We are going to multiply by our R. And we can't just multiply just R. We're going to go R to the n minus 1. So what's happening here? On our first term, if I plug a 1 in for both of these n's, that'd be my first term. We'd have 1 minus 1, which would equal 0, which means R would not be a factor, and we would just have a sub 1. When I look for my second term, 2 times 1 means I'm multiplying by 1R. When I plug a 3 in for this n, 3 minus 1 is 2. That means I'm multiplying by 2R's, then 3R's, then 4R's. So this is setting us up for how many times I multiplied by that R. That will get us to our term. So I do think this explicit makes sense if we can think about what exponentials are. I do want to point out this is an exponential formula. It's a good thing to recognize that because soon we're going to have to determine whether something is geometric or arithmetic. And it might come down to I show you the formula and you have to decide if it's geometric or arithmetic or neither. If it's exponential, it's most likely going to be geometric unless something weird is happening down here. So a sign that you have an explicit geometric sequence is the exponential. So look out for exponential in those. So our first example is list the first 4 terms. So this should be exponential, which we can see right here. I can see this is geometric just by looking at it. It's 3 to the n. I should right now start thinking about, okay, if it's exponential, it means it is geometric. So I should come up with some kind of geometric sequence. All right, so listing the first 4 terms, we would list the very first term would equal 3 to the first. Well, that just equals 3. Our second term is 3 squared. 3 squared is going to be 9. Our third term is 3 cubed. Well, 3 times 9 is 27. And finally, our fourth term, 3 to the fourth, what is that going to be? 60 plus 21, so that would be 81. And if we note, this is geometric. because we are multiplying by 3. But I would probably make a note of this because this is important. If it's exponential, I already know it's geometric. I shouldn't have to do this check to make sure it's geometric. I should have started off going, oh, that's geometric. In fact, if I get to the next one, I should go, that's also geometric. Not only is it geometric, we know something about it. So it's exponential, it's to the n minus 1, so it's geometric. I also know my common ratio is r, and I know my first term should be 100. So I know all that from this equation. I know what my first term should be, I should know what my common ratio is, and I should know it's geometric. All three things are right in order. So our first term should be 100. Let's check out if we can do it correctly. So a sub 1 is going to equal 100 times 1/2 to the 1 minus 1, which is 0. I guess we can write out the whole thing. Well, 1/2 to the 0th power is 1. Anything to the 0th power is 1, so it is just going to be 100. For a sub 2, we're going to have 100 times 1/2, and I'm just going to kind of, we'll do it all. So we have 2 minus 1 equals 100 to the 1/2 to the first. Well, that's multiplying 100 times 1/2, so that's going to be 50. A sub 3 is going to be equal 100 to 1 over 2. On this one, I'm going to shortcut a little bit. I'm going to have 3 minus 1, which would be squared, which means we're doing 100 times 1 over 4, which equals 25. And our last one is a sub 4, which would equal 100 times 1/2. Well, 4 minus 1 is 3, so it would be 1/2 cubed, which would be 100 over 1 over, well, 2 cubed is 8. So it would be 1 over 8, which is going to equal our 12.5. And we will notice 100, 50, 25, 12.5. That is half, 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 half. It is geometric. Once again, the sooner you know that this is geometric, the easier life is when we get to ones where I'm just like, choose. Choose what kind this is and deal with it how you can deal with it. The sooner you get to that, the easier life is. All right, so I'd have somewhere maybe in my notes that exponential is geometric. All right, these next ones we're supposed to write a formula for general term of each geometric sequence. Write a formula for the general term. What does that mean? Well, that's just another way to say explicit. A formula for a general term is the definition of what an explicit is. Write a formula for a general term means plug in 100 and get out your value. So each of these we're supposed to determine, is it a geometric sequence? If it is, we're supposed to write an explicit formula. Well, I'm looking at this one, and it's definitely not arithmetic. If you just look, there's not a number I can subtract that does this. If we look for our R value by doing our second term divided by our first term, we're going to realize that comes out to 0.1 or 1/10. And if you multiply all of these by 1/10, you can get to the next one. 0.3 times 1/10 is 0.03. 0.03 times 1/10 is 0.003. 0.003 times 1/10 equals 0.0003. So we got an R value of 1/10. It is geometric. And we just need our R value and our first term. Our first term is 0.3. Once we have our common ratio and our first term, that means we can go ahead and write our formula. Our explicit formula is going to be a sub n equals the first term times our common ratio. Now let's put our common ratio in parentheses to know that the whole thing is being raised to the power of n minus 1. I do think it's nice that it's n minus 1 because in your arithmetic sequence, it's also n minus 1. So in both explicit arithmetic and geometric, you should be using an n minus 1, not just an n. All right, our next one seems to be alternating between positive and negative. This is not a problem for geometric. What number would I multiply 2 by to give me negative 6? Negative. We would multiply by a negative 3. So that would be my starting off point. Is this geometric? I'd be multiplying by 3. Well, negative 3, sorry. If I multiply negative 6 by a negative 3, we are going to get 18, so that works. 18 times a negative 3. Maybe I should put those negative 3s in parentheses so it doesn't look like x minus 3. That also works as well. So this is geometric. So with it being geometric, we just have to get our r value. Our r value equals the whole negative 3. Our first term is 2, which means our formula is going to be a sub n equals our first term, which is 2, times our r value to the n minus 1. So if it's alternating between positive and negative, we just got to make sure our value is negative to match that alternating. That every time you multiply by negative, it switches from positive to negative. All right, our next one, 6, 8, 10, 12. Does that look geometric? No, it's arithmetic. This is arithmetic because it would actually be a plus 2. So in my mind, I always check if it's arithmetic first. And it is plus 2, so that's arithmetic. And it doesn't say we have to do anything if it's arithmetic. If you want to write your arithmetic formula down, I'm just going to say it's arithmetic because we're on a geometric unit. All right, our next one says 1/2, 1 over 6, 1 over 18, 1 over 54. Is this geometric? If so, what is your common ratio? If so, what is your common ratio? Ooh, it rhymes. It's a rhyme day. Sam? 1/3. Yep, 1/3 is going to be our common ratio because 1 over 6 times 1/3 equals 1 over 6. 1/3 times 1 over 6 equals 1 over 18, and times 1 over 3 does equal that 54. So we do have a common ratio equaling 1/3. As always, if you're ever confused at what your common ratio might be, you can always do r equals 1 over 6 divided by 1 over 2, which would have came out to 1 over 3 as well. Which gives me my first term equals 1/2, which gives me a pretty sweet equation of a sub n equals the first term times your common ratio, which is 1 over 3, times your n minus 1. All right, the very last thing we're going to do is we're going to find the first 4 terms of sequence, and then we're going to determine if the sequence is geometric. You should be able to just right off the bat go, it's geometric or it's not geometric by looking at the equation. So if I look at the first one, we have negative 2 to the 3n. That's exponential. That's exponential. So if I wanted to, I could automatically go, exponential means it's geometric. It does say I'm supposed to list the first 4 terms, though, but I should know it's geometric when I get done. So the first 4 terms is going to be b sub 1 equals a negative 2 to the 3 to the first. Well, that's negative 2 to the third. So that's negative 2 times negative 2, which is a positive 4, times a negative 2 is going to be a negative 8. My second term would be negative 2 to the 3 times 2, which equals negative 2 to the 6th. If we do not have our calculator out, we could do that. It would be negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which would equal a 64. Our third term would be negative 2 to the 3 times 3, This is where I definitely pull out my calculator, and we should come out to a negative 512. And our last term would be negative 2 times 3 to the times 4, which would equal 4,096.
My computer gave a negative 64.
It gave a negative 64.
Yeah.
That's probably too small because we're going 2 to the 12th power. Did you do negative 2 to the 12th?
I did negative 2 to the 6th.
It would be to the 12th.
No, I'm talking about 64.
This one?
Yeah.
What it gave out as?
It's negative 64.
Make sure you put the parentheses around the negative before you raise it to the power.
Oh.
So what you probably did, and is very easy to make, is you probably did negative 2 to the, what are we doing, to the 6th? Your calculator is going to do that 2 to the 6th and then tack a negative onto it. So it'll make all of them negative. What you need to do in your calculator is to make sure you put the parentheses around that negative 2. That's why I'm being very careful on this one to put parentheses around this and raise it to the power, because that's exactly what you need to put into your calculator. Otherwise, they're all going to come out negative. And that's going to be a problem. But it should alternate between negative and positive. If we look at all of these, to get from negative 8 to 64, you'd multiply by negative 8. Negative 8 times 64 equals negative 512. Negative 8 times 512 is 4,096. It is geometric. Your R value is that negative 8. All right, our next one, a little more uncertain, but I'm pretty sure it's geometric because look what's happening. The term I want equals the term before it times a negative 2. So just looking at this, you should know it's geometric. It is multiplying, which means it should be geometric. Let's check it out. So we would have a sub 1 equals 1.5, or 1.25. Oof, don't skip numbers. My second term is going to be negative 2 times the term before it. The term before it is 1.25. So we have a positive 1.25. We're multiplying it by 2. That's going to equal a negative 2.5. Then our third term, well, that's going to be negative 2 again times the term before it, which would be a negative 2.5. That would equal 5. And finally, our fourth term would be negative 2 times that 5, which equals a negative 10. I am going to note that I'm just doubling. I'm doubling by a negative 2. So 1.25 times negative 2 equals a negative 2.5, times a negative 2 equals 5, times a negative 2 is negative 10. I assumed it was geometric, and it turns out it is geometric. Our final one, I'm going to say, okay, that's not exponential. It's not exponential. It looks like I just have 3n. From yesterday, you should look at this being arithmetic. This is an arithmetic sequence. 3 times n. Yesterday, we said our arithmetic sequence usually broke down to like 3n plus 2 or something. So we need to start realizing that this is arithmetic as it's written out. So I'm assuming it's arithmetic. Putting it in, we have c sub 1 equals 3 times 1, which equals 3. Our second one is 3 times 2, which equals 6. Our c sub 3 equals 3 times 3, which is 9. And finally, our c sub 4 equals 3 times 4, which equals 12. Yep, I am adding 3 to each of these. Plus 3, plus 3, plus 3. I assumed it was arithmetic, and it is, in fact, arithmetic. I'm going to tell you right now, it's going to be really important for you to realize arithmetic and geometric when we get to series. Because in series, it will not say, is this arithmetic or geometric? It will just say, calculate a sum. And calculating a sum is dependent on you knowing whether it's arithmetic or geometric when we get to series. So practice right now recognizing whether things are arithmetic or geometric just by looking at the equation in those problems. All right, questions on anything we covered? Shouldn't be that big of a shock. We did addition yesterday. Today we did multiplication. On Monday when you come back, we're going to do assorted ones. The ones that don't quite fit into either box, but we can actually put into one of the boxes.